We're going to talk now a little bit about the network, about the internet, and how to interact with it through a code. So eventually that's what we want to do in our Internet of Things, our IoT devices. We want to be able to write code that talks on the network. So we'll talk a little bit about that and start introducing the internet and its protocols and how it works. So programmatic networking. So by this I mean using the network through code, through a program. Now, accessing a network on a Raspberry Pi or really any device as a user is pretty straightforward. Okay, we've seen this. You just go to your machine, you connect to the network, open a browser, for instance, open an email application. You open some appropriate network application and you work with it and you run it, and great, a user can interact on the network. What we want when we're making these IoT devices, we want not so much direct manual interaction. We want some program that's running on our IoT device to be able to actually interact on the network. So we want that program, it should be able to talk to other servers, other machines on the network and get data from those machines, request services from those machines. So the Raspberry Pi then isn't the only device that's doing the work. So it can offload work to a foreign machine or remote machine and get results back. And so from the user's point of view, the whole system is much more complicated and interesting, right? So you can have interaction between the network and some network servers and the world, with the Raspberry Pi basically in between, or the Raspberry Pi or whatever your IoT device is. It's in between, getting data from the world, right? Interpreting that, sending it to the network, getting some service, getting results back to the Raspberry Pi, whatever your device is, and then sending actuations out to the world, putting something on a screen, making something happen. So that's what we want. That's what Internet of Things is really supposed to do. It's supposed to take this environment, this natural environment, and interface it with the network somehow. So, for instance, you have a little cloud over there that's the internet, right? That's the internet and some servers on the internet that you might be interacting with, maybe providing some kind of service that you want. And then there's a Raspberry Pi, which is remote, somewhere local, right, remote from the servers. And it has sensors and actuators, because though it's implementing this embedded device, right? It's IoT device. It has actuators that do things out in the real world and sensors that read data from the real world. So sensors meaning buttons and things like this, light sensors, sound sensors, microphones, whatever you want. And then it has actuators, speakers, screens, motors, that type of thing. And so the Raspberry Pi is directly interfacing with the real world through these sensors and actuators, and it's trading data with some servers based in the internet, some servers connected by the internet. So you get the whole system that the person is interacting with is much bigger. It's not just the Raspberry Pi, it's this whole networked infrastructure. That includes some servers that are on the network. Okay, so for this we'll talk a little bit about the internet. We need to explain what the internet looks like in order to have you writing code that actually accesses the internet. So the internet, the structure of the internet is relatively ad hoc. Not completely, but remember that it's not completely controlled, right? At any time, I can open up a laptop and have it connect onto the network, and now it is a node on the internet. And then I can close that laptop, and it is no longer a node on the internet. Or I can say, look, I'm going to buy a router and turn on my router and connect 10 machines to the internet through my router, right? So the structure of the internet is not a fixed thing. It's not centrally controlled. It's controlled locally by all sorts of random people. Anybody who wants to start a connection and has a little money can spring up their own little subnetwork, right? So you've got this set of local area networks, LANs we're calling them, LANs, local area networks. And those things are out of control, okay? You don't know what those things look like, what protocols they use. That's up to whatever the locality is. I mean, there are certain standards, but people don't have to adhere to those standards necessarily. So everybody has their own local area networks, and these are all somehow tied together into one massive internet, and they all have to talk together. So these local area networks are connected by, well, I'm drawing a sort of a hierarchy of routers in this picture. It doesn't have to be routers, it can be switches and bridges and things like this, but networking infrastructure. A hierarchy of this, a massive hierarchy, that all communicate together to form the internet, okay? Now, this is a vast simplification, but at the general idea is at the bottom, at the local area network level, that's out of control. At the top level, there's got to be some structure imposed so that everybody can talk together. So, so the structure imposed, the way all these random local area networks talk together is through the use of these internet protocols. So you need to send data from one local area network to another, and you don't have control over the individual networks, but they still need to communicate somehow. So how do you do this? Generally, you use a protocol, and internet protocols, right? Now, protocol is basically a set of rules that define a lot of things. They define the communication. So they define how data should be transferred between two different nodes. They define what data is contained in each packet, define what's in the header. They define a lot. But the protocol defines how you should communicate. Just to give you a little example, you ever seen movies where people talk on a CB radio, and they say, they'll talk, and every time they're done talking, they say over, and then the next person is allowed to talk. And then they talk, and they say over, right? That's protocol. The protocol is you say whatever you want to say, and then you say over to let the other person know you are done with whatever you're saying, and they can talk. And the reason why you have that protocol is to share the communication lines, because basically with a radio like that, you have one set of lines, one communication channel. So only one person can be talking at a time. So you need some signal to let the other person know, okay, I am done, I am relinquishing control of this bus so that you can talk now. So that's why you say over, right? And then when you're done with all your communication, you say over and out, meaning you want to end communication completely. And that's called a protocol. It defines basically how you're supposed to communicate. It gives you some rules. Now, it doesn't define everything. It doesn't define what you can say. You can put any data inside the packet and the payload, right? The words you say, you can say whatever you want, as long as at the end you say over, right? Or at the end of the whole communication, you say over and out. So that's a protocol. And you get this, in the network, it's the same thing. You have, usually the extra information isn't at the beginning, isn't at the end, but at the beginning. So with this example that I'm giving here with over and out, you say that after you're done with your payload. You say your payload, then you say over. So that's a footer. They call that a footer because it's at the end. Usually in the internet, most of these network protocols, you have headers. So you put that network information at the beginning of the packet. You say things like, what's the destination address? You put that at the beginning. What's the size of all the data? You put that at the beginning. Things like this. You put this information at the beginning, and then you put your payload out there. But it's the same idea. So there are a set of these internet protocols. And the idea is, in order for two machines on two random local area networks to communicate, they have to adhere to these internet protocols. So when they want to talk, when one machine from one local area network wants to talk to another machine from another local area network, it has to adhere to the protocol. It has to encapsulate data the way that the internet protocol dictates. And as long as it does that, the machine at the receiving end will understand that data and be able to pull out the information that it needs, and they can communicate. And these protocols don't interfere with the LAN protocols. So these local area networks, they can have whatever protocols they want. As long as, so that we would call the payload of the message, right? They can have whatever information in them they want, as long as you put the special header for the internet protocol on the outside of all that, you can send whatever data you want. So the local area networks can have whatever random protocols they want to have, as long as you adhere to these internet protocols and put their headers on the front and footers if you have to on the back, then the two machines can communicate. Thank you.